Making sense of indices. In this lesson we'll see what indices are, we'll look at the index clause and discuss zero and negative indices. Is there a shorthand way of writing 2 plus 2 plus 2 plus 2? Yes, there is, and it's multiplication, 4 times 2. Multiplication is just repeated addition. Is there a shorthand way of writing repeated multiplication? 2 to the power of 4 is how we do it. Indices tell us that we have repeated multiplication, not addition. The 2 is the base, that tells us what to multiply. And the index tells us how many times we're multiplying that base. An index is also referred to as an exponent or a power. Starting with 2, we'll multiply that by 2 to get 2 squared, which is 4. Multiplying by another 2, we'll get 2 to the power of 3, which is 8. And multiplying by another 2, 2 to the power of 4 will give us 16. And times another 2 will give us 2 to the power of 5, that is 32. Now notice the powers there are going 2 to the 2, to the 3, to the 4, to the 5. So starting with 2, the power is 1. So 2 is 2 to the power of 1. Can we simplify 2 to the power of 3 times 2 to the power of 2? 2 to the power of 3 is 2 multiplied by itself 3 times, and 2 to the power of 2 is 2 multiplied by itself twice. So we have 3 lots of 2 and 2 lots of 2 being multiplied. So we have 5 lots of 2 being multiplied altogether. We can see that all we had to do was add those two indices. Now this will work for any base, it doesn't have to be 2. So we can represent the base as A, and it'll work for any powers as well. So we can generalize that and say a to the power of m times a to the power of n equals a to the power of m plus n. That is, when the bases are the same, we can add the indices. Can we simplify 2 to the power of 3 divided by 2 to the power of 2? We have 3 lots of 2's that we're multiplying by and 2 lots of 2's that we're dividing by. Multiplying by 2 and dividing by 2 will cancel out. That means we have 3 minus 2 lots of 2's left. We are subtracting those indices, leaving us with 2 to the power of 1. This works for any base and for all indices, and so we can generalize this and say a to the power of m divided by a to the power of n can be obtained by subtracting those indices. So we subtract those indices provided that the bases are the same. What about having 2 to the power of 3 that is then raised to the power of 2? So the squaring just means that we're multiplying by itself, and we are multiplying the 2 to the power of 3 by itself. And of course, because we're multiplying, we add those indices to give us 2 to the power of 6. We can get that power by multiplying those two indices, 3 times 2. Once again, this works for any base, so we'll generalize this and say a to the power of m to the power of n is a to the power of m times n. That is, we multiply those indices. We'll use this pattern to give meaning to zero and negative indices. We can see that the powers on the left-hand side are decreasing by 1 as we go down that list. So the next one will be 2 to the power of 0. And on the right-hand side, we're dividing by 2 as we go down that list. So 2 to the power of 0 will equal 1, that is 2 divided by 2. The next entry in that pattern is 2 to the negative 1. and that'll be equal to 1 divided by 2, which is a half. Continuing on, we will get 2 to the negative 2 is 1 over 4, and 2 to the negative 3 is 1/8. Now this will work for any base, so we can generalize that and say a to the power of 0 is 1. For example, 7 to the power of 0 is 1. And a to the negative n is 1 over a to the n. For example, 10 to the negative 3 is 1 over 10 to the 3. Indices are used as a shorthand way of writing repeated multiplication. A to the power of m means a multiplied by a times a m times. Notice that it is not the same as a times m. When we're multiplying two numbers with the same base, a, we can add the indices m and n. Whereas when we're dividing the numbers with the same base, we subtract the indices. And if we raise a number to a power and then to another power, we multiply the two indices. A to the power of 0 equals 1, and a to the negative n means 1 over a to the n.